Good morning, everybody. My name is Emmanuelle. I'm a physics researcher in a joint lab with the industry, and I'm also a developer of the Scikit-image package, which is a Python package for image processing. So, why a talk about image processing in a PyData conference? Nowadays, images are among the most voluminous source of data that we have to face. Thanks to this little guy's cheap CCD sensors, and thanks to the facility to broadcast them on the internet, we are now confronted to a massive flood of images. A few examples. Oops. Sorry for this interruption. So, a few examples about the flood of images. Nowadays, every day, hundreds of millions of images are uploaded every day on Facebook, and it's still growing. So it's a safe bet to say that there are massive business opportunities in there. And in science as well, a lot of science projects acquire images for which the typical unit is the terabyte. So it's the case for solar research, but it's the case in my field as well. So for all these applications in business and science, you need to perform image processing. That is, so image processing is a whole branch of applied mathematics, but I will use here the very loose and practical definition that image processing is transforming images into other images or to extract some information out of the images. On the market, you can find a very large variety of tools for image processing. Some of them are fantastic tools like OpenCV, a package for computer vision with really good Python bindings. So why yet another package for image processing? Basically, it all boils down to the simplicity of the package of Scikit-image and to its compatibility with the whole NumPy ecosystem. So I will show you a few examples of these interesting features of Scikit-image during the talk. Especially, I will focus on the learning curve. If you're already using NumPy, SciPy, maybe also Scikit-learn, then the cost of starting using Scikit-image for image processing won't be that high for you. And I will show you also that it's quite a versatile package, and you can start using it now for a large variety of use cases. Before I move on to detailing such points, here's a small datasheet about Scikit-image. So I promise this is the last boring slide with bullet points. I know you're all eagerly waiting for code and images. So what I want to say here is that today Scikit-image benefits from quite a healthy growth. We're growing quite a lot. And it also strives to enforce the good development practice that made the success of the core packages of the NumPy ecosystem, such as NumPy, SciPy. The main developer of the package, Stefan van der Walt, is also a SciPy developer, and I should say that the members of the core team are mostly practitioners, not mathematicians, which means that they are close enough to applications to want reasonable trade-offs in terms of algorithm and coding practices. So I will start with the compatibility of the Scikit-image with NumPy and NumPy arrays. For Scikit-image, grayscale 2D image is just a 2D NumPy array like this one, where each pixel is an element of the array, and the value encodes the gray value of the pixel element, like here, 0 or 1. And if you want to use color images, then you just add one dimension for the color channels. And obviously, if you have a 3D grayscale image, then you just have a third dimension for your array elements for your pixels. Therefore, in Scikit-image, functions take NumPy arrays as inputs and outputs. So here's a little example of what you can do with Scikit-image. After importing some submodules, you will read an image from an image file, and then by asking for the type of the object, you see that my image is just a plain NumPy array. We used at the beginning of the project to have another abstraction on top of the array, an image class, but then we ditched it because it was too complicated, and now we just have plain NumPy arrays. After you get your array, you can apply a function of Scikit-image. It's just a Gaussian filter to smooth the image on your array, and what do you get as an output? Guess what? It's also a NumPy array. And since you stay with NumPy arrays, the good thing is that you can use the other packages of the NumPy ecosystem, like Matplotlib if you want to visualize the image, or even Scikit-learn if you want to. The whole Scikit-image API relies very much on functions. We don't have fancy classes or anything. Here is an example. You see also that a lot of the complexity of the function often lies in the keyword arguments that you have here. So it's a very nice possibility of Python to hide what's more complex in optional arguments. And you can also see that this docstring might look familiar to you because it follows completely the NumPy standard, docstring standard. That's why it's really well integrated within the NumPy ecosystem. So docstrings are really good if you want to learn more about a package, but in order to smooth the learning curve, it's also important to have a good website. As far as documentation goes, Scikit-learn sets a very, very high standard. So in comparison, I would say that the website of Scikit-image that's here, it's pretty good, but it still needs some love in terms of user documentation. What's really good, though, is the graphical user gallery. So such a gallery is now a common feature among several packages of the NumPy ecosystem, like Matplotlib, Scikit-learn. And so you have a list of examples with pictures, and you can just click on one of the examples if it's something that more or less looks what you want to do. And then you still have the picture, but more importantly, you have the code that generates it. You can download it, you can play with it. So it's a very convenient way of learning more and keep learning some skills about image processing. So I now move on to a very brief description of some tasks that you can perform with Scikit-image, and I will start with image filtering. That is roughly transforming images into other images. For example, you may want to denoise some images that are quite noisy. A lot of people don't know that their life will be much easier if they start by denoising their image before going further. And so, by the way, all the examples that are here, they are, most of them at least, they are taken from the user gallery, so that you can just go to the website, find the image again, and look at the code. And here is a comparison of different denoising algorithms. And can you hear me when I have the mic here? Or is it too? It's okay? Yeah, maybe it's better like this. So you can use very classical denoising algorithm like median filtering, but you can also try more fancy things like total variation denoising, and it's an important feature of Scikit-image. It's that the basic stuff is here, but if you want to do some more advanced things, some of them are already coded in Scikit-image. So it's also a good way to discover more image processing algorithms. So I've put here a few other examples of filtering, like contrast equalization or edge detection. All of them, you can find them. It's a bit like a laundry list of image filtering. And what's of interest also to the PyData crowd might be the feature detection. So extracting some features from the images to feed after to a classifier or an estimator of the Scikit-learn package. And these features, conveniently located in a Scikit-image feature submodule, can be, for example, points of interest like corners or edges, or local statistics or neighborhoods, or local configurations of package of pixels. And after, of course, it's possible to feed these features to one of the algorithms of Scikit-learn. For example, here, a random forest classifier that I use to do a segmentation of this picture. It's also important to be able to transform images like rotation, zooming, scaling, especially in computer vision. And I will now switch to an important task that you often want to perform in image processing, that is image segmentation. Image segmentation is the ability to label different pixels with different, to attribute them to different regions, to separate objects, and to be able to perform statistics after, for example, on these objects. And once again, you can go from very simple things to a more advanced one. Very simple things can be, for example, histogram-based segmentation, so just thresholding. But you can do more fancy things like using superpixel methods for further classification, for example, or separating connected objects. All this you can find on the gallery and learn more about image segmentation with Scikit-image. After you've done image segmentation, so you have some regions, and in order to do some science out of it, usually you want to compute statistics on these regions, and you have a whole sub-module for this, Scikit-image measure, implementing a lot of different measures on the regions. And one of the very useful functions implemented in this module is a label function that attributes a different label to different connected components. And I will use this function to show you an important aspect of Scikit-image, that is its versatile aspect, the fact that you can use exactly the same API for 2D images or 3D images. Here, I gave different labels to connected components to a 2D image, and here to a 3D image, and it's exactly the same syntax. So for me, it's a very useful feature, because in my lab, we're processing 2D images from microscopy, but also 3D images from tomography, and I don't want to change the API to use different packages when I'm switching to 2D images to 3D images. So it's a feature that I appreciate a lot. Okay, so to wrap up, I hope that I have convinced you that if you're already using some modules of the NumPy SciPy ecosystem, it's not very difficult to start using a little bit Scikit-image. If you have some image processing problems, you might find an example on the gallery that looks like something that you would like to do. So I said that we are still growing, so it means that we need both feedback and citations. So for citations, we have a paper of last year, and of course feedback is very welcome on the GitHub repository. Thank you.